Hello there and welcome back to topic 2 of the operating systems chapter. In this video we're going to talk about interrupts and we're going to describe a range of conditions or events which could generate interrupts. We're also going to describe interrupt handling and the use of priorities and describe factors involving the allocation of different priorities. So let's get cracking straight away then. An interrupt in the computer sense is a signal sent from a device or software to the processor. And the job of an interrupt is to stop the current job which is on the processor and causing an interrupt to the system. Hardware and software can trigger interrupts using something called an interrupt service routine or an ISR. Think about a dinner party when a waiter's walking around with canapes. They don't go to everyone asking them individually, would you like a canapé, would you like a canapé, would you like a canapé? What we do here is you walk around and wait to be called. So once an ISR is called, the operating system will trigger the events. And in order to trigger the event that we want to happen, we have to stop the CPU. And that's what an ISR does. It runs some special operating system code to inform of an interrupt. We take the state of the current CPU and put it on a stack, and that's important because later we're going to retrieve it so that we can continue what we were doing before. Now, priority is very important at this point. If we have a very high priority, then that is going to be the information that's going to get ran first. If what's currently running on the CPU is of a higher priority, then we continue to run that and we don't interrupt what the CPU is doing. So if we do make a swap and the information is moved onto the CPU, we need to make sure that we can take the things off the stack later on, pop it off the stack and put it back on the CPU and continue like nothing was changed. And there are a few different common interrupts that we see day to day. The hard drive, for example, could be ready for more data and that would send an interrupt to our processor. It could be a timer interrupt has occurred. It could be a 15-minute timeout function, for example, on your computer. A key has been pressed. It could be a mouse or a keyboard key. That will cause an interrupt to your system. Or peripheral devices require more data, such as a printer or a scanner. The on and off button on your computer has been pressed. Obviously, that has a very high priority. Hardware failures or a problem is encountered, that will take over the priority of your system and interrupt your flow of your CPU. And interrupts allow the CPU to make much better use of time. Remember, we don't want our CPU to sit idle at any time. And now we move on to buffers and interrupts. A buffer is a small block of memory inside hardware devices such as printers, keyboards, hard drives, and where work is currently being handled by the device that needs to be stored. So think about how a buffer would work. A key is pressed, an interrupt is sent to the CPU, and the keystroke is stored in the keyboard's buffer. And that means we won't lose any data that has currently been pressed. And sometimes the operating system may not be ready to deal with the keyboard stroke and more keys have to be pressed. So that means we need to make even more use of the buffer. But what happens if the buffer becomes full? Well, if the buffer becomes full, then we overflow the buffer and then your motherboard will make a beep sound. Now in modern computers, because of the size of buffers and memory and things like that and better use of the processors, you don't tend to hear these normally, but that does sometimes happen. So when data is stored or loaded from any device, buffers will be used. And this is the process of a buffer. A chunk of data is sent by the CPU to the device and stored in a buffer. The device will slowly save the data while the CPU is free to do other tasks. When the buffer is empty, an interrupt is sent to the CPU asking for more data. At the start of the next clock cycle, the interrupt is processed by informing the operating system, and more data is sent to the device and the cycle repeats. So think about it like this. It's an empty glass. As the glass fills up and gets all the way to the top, we have to send an interrupt service routine saying we need to be processed because we're full. Then if the glass is empty, we need to send an interrupt service routine saying the glass is empty, we need more data, give us more data. So if you know what single buffering is, double buffering shouldn't be too unfamiliar to you. Sometimes more than one buffer is needed and is used. What happens here is the first buffer is used for accepting data, while the second buffer is used for processing. The operating system would write the data to the first buffer and the device will use the second for processing. So once the data is processed, the first buffer is copied into the second and an interrupt is sent. That way, there's no delay while the interrupt is being processed, meaning that the device will have a much higher active time. Now, when we're dealing with interrupts, it's important that we have priority. It's working out who is allowed on the CPU at any one time. So, in our society, who has the highest priority? Well, the boss does. Her Majesty the Queen, she's the most important person in Great Britain, apparently. So what happens here is if she is stood in a queue, she's going to be at the front of it because she's the most important person. So if we declare an interrupt, we need to check the priority of the currently running process and then interrupt. If the interrupt priority is greater than the current executing process priority, then we have to swap the tasks on the CPU. If not, we simply don't swap the tasks and we wait for the CPU to become available or a lower priority task on the CPU that we can swap out. And there we are. We've looked at a number of different things in this video. We've looked at interrupts and how we can generate interrupts, the use of interrupt handling and priorities, and also the use of buffering. In the next video, we're going to be looking at memory management, including paging and segmentation, and virtual memory. We're also going to look at scheduling and process states, time slicing, polling, and threading. They'll all be included in the next video. Hopefully I'll see you there.